So the question is the last question from the Patron duopoly problem set. So it's the hoteling game with non-uniform distribution. So in class we did the uniform one, so from 0 to 10. So what happens is there are continuum of consumers here. So I think that was one thing that was actually confusing in the question too. So there are continuum of consumers. So there are one unit. I don't know how many people, but there's one unit uniformly distributed within this of consumers uniformly distributed within this one unit of distance. So that was what happened in class. What happened here is not only it's not uniform, it's also not continuous. So what we have here is at here there's no consumer. At here there's one person basically standing here at one. So it's not uniformly distributed along this. It's just one person standing here. And there are two people standing here at 2, so there are basically 10 people. So I don't want to draw this times 10 at location 10. So it's starting from 0 to 10. So how many people do we have? So it's 1 2 3 until 10. So what this is 55. Yes, I think so. So it's 1 plus 10 times 10 divided by 2. So it's 55. So the trick that I did in class is still applicable. So the solution I had is the normal way of doing it, which is writing down everything. On the exam, as I said, if you know some kind of intuition, you don't need to write down everything. So the trick is there is some place called the median. The theorem, there's actually a theorem called median voter theorem, which we all do in 326. What it says is, I don't care what distribution it is, it's continuous, it's discrete like this, but in at some place there is a median, so there is something like here, where, no, that doesn't look like it. So say it's something like not on the top, but say here. Then on the left, there are half of the distribution. On the right, there are half. So this point is called the median. So if you have taken 220, then you know that what the definition of median is. So basically on the left there is half, on the right there is half. So what happens here? So I guess I'll use this diagram as diagram. So the question is not exactly this, but I'll just suppose it's this. So basically what happens is if we are on the left of the median, so in class we said if we are on the left of 5, then we want to be a bit right. Here, suppose the other food truck, say food truck 2 is here. Where do I want to be? So that's how you think about these problems. The best response means given the other player's action, what do I do? So do I want to be here? No, I want to be a little bit here, right? So I want to be here so that I can share the half in between and get everything here. And you know this one is the median. So what it means is there are at least half of everything here, and there is also I get some more. So basically what happens is my best response is very easy to write down. Given the other person, I want to do the other person plus 1 if the other person is located somewhere on the left of the median, wherever the median is. So in this case it's 7. But if the other guy is located at the median, then I want to do the same. So if this is equal to the median, and the 7 number here is that doesn't matter. I don't really know if it's 7 or 8, but anyways, and on the right I want to be on his left. So if this is larger than the median, so again we should draw this thing maybe. So no. So suppose it's like this. Then suppose the median say is here, and suppose the x minus I, so food truck number 2 is here. Then where I want to be? I don't want to be here. Here I can get at most less than a half. If I stay a bit to the left of the other guy, then I can get everything here, which there's a half. So there is more than a half, plus we share this thing in between us. So that's the place I want to be. So I want to be to the left, a bit left, and here I want to be a bit right. So that's how you write down the best responses. Given these best responses, obviously you can see that x1 equal to x2 equal to the median is the only Nash equilibrium of these games. And this result It's called the median voters theorem.